everyone, welcome to the chemistry guide. Today's topic is ionization energy. What is ionization energy? The minimum amount of energy required to remove the outermost electron of an isolated gaseous atom to form cation is called ionization energy. Here, this is an atom. These are orbits. Electrons are present on these orbits. The electrons in the outermost orbit are called valency electrons. We know that these electrons are attracted by the nucleus. However, the valency electrons experience less attraction compared to the inner electrons. So, the minimum amount of energy required to remove this outermost electron of an isolated gaseous atom is called ionization energy. Ionization energy is measured in kilojoule per mole. Here, remember, firstly, ionization energy is minimum amount of energy. Secondly, ionization energy remove the outermost electron from atom. Thirdly, ionization energy convert the atom into cation or positive ion. Why is ionization energy measured in the isolated gaseous state? Well, isolated gaseous state means that atom is present in the ground state. In solid or liquid state, it means that is present in combined or bonded state. For example, consider bromine molecule. If we want to find the ionization energy of bromine in this bonded state, here very high energy is required to remove an electron from this bonded bromine molecule and it incorrect value of ionization energy. We take isolated gaseous atom of bromine and then find its ionization energy. Therefore, we said that ionization energy is always measured in the isolated gaseous state. Here, we must also want to learn what is first ionization energy, second ionization energy, third ionization energy. First ionization energy. What is first ionization energy? The minimum energy needed to remove the first electron from neutral atom is called first ionization energy. Consider magnesium atom. Its grounded state, if we add 738 kilojoule per mole energy to the magnesium atom, it will lose one electron and it will become unipositive ion. So, this 738 kilojoule per mole energy is called first ionization energy. First ionization energy can convert an atom from ground state to unipositive state. Next, second ionization energy. After removing the first electron, the atom becomes positively charged. Removing another electron from this positive ion requires more energy. So, the energy needed to remove the second electron is called second ionization energy. This unipositive ion of magnesium, now we add 1450 kilojoule per mole energy to the unipositive ion of magnesium. It will lose another electron and it will become dipositive ion. This 1450 kilojoule per mole energy is called second ionization energy. Remember, the second ionization energy converts unipositive ion to dipositive ion. Next, third ionization energy. What is third ionization energy? after removing two electrons from the ion becomes even more positive. Removing the third electron needs even more energy. So the energy required to remove the third electron is called third ionization energy. Now if we add 7732 kilojoule per mole energy to the dipositive ion of magnesium, it will lose one another electron and it will become tripositive ion. This 7732 kilojoule per mole energy is called third ionization energy. Remember that third ionization energy converts dipositive ion to tripositive ion. We consider third ionization energy is greater than second ionization energy and second ionization energy is greater than first ionization energy. Why second ionization energy greater than first ionization energy? Here I am taking second ionization energy. We already learned that second ionization energy remove an electron from unipositive ion like magnesium ion. Here unipositive magnesium ion has 12 protons, 11 electrons. Due to this, nuclear attraction increases and electrons are tightly held by the nucleus. So, we need very high energy to remove an electron from the unipositive ion. And therefore, second ionization energy is greater than first ionization energy. Here, magnesium valency is 2 only because you need 7732 kilojoule per mole energy to remove third electron from this magnesium, which is very high. Factors affecting ionization energy. There are 3 factors. Atomic radius. Here I am consider hydrogen and potassium. The atomic radius of hydrogen is small and the atomic radius of potassium is large. It is hard to remove this electron from the nucleus because of more attraction between electron and nucleus. When atomic radius is small, ionization energy is high. Secondly, it is easy to remove this electron from the nucleus. When atomic radius is large, attraction between nucleus and electron is less, so that we can easily remove the electron from the nucleus. So, ionization energy is smaller. Therefore, we said that here is inversely relationship between atomic radius and ionization energy. Next, nuclear charge. Here consider lithium and fluorine. There are 3 protons and 3 electrons in the lithium atom, while fluorine has 9 protons and 9 electrons. The size of fluorine is smaller than lithium. Because of greater nuclear charge, it is easy to remove an electron from the lithium atom. So, smaller nuclear charge means smaller ionization energy, while it is very difficult to remove electron from fluorine atom. So, greater nuclear charge means greater ionization energy. Therefore, we said that there is directly proportional to nuclear charge. Next, nature of orbitals. We know that S orbital is near to the nucleus when comparatively P, D, F are away from the nucleus. So, ionization will be high when we remove an electron from the S orbital. Ionization energy will be smaller orbital. Why ionization energy decreases down the group? Well, consider first group elements like lithium, sodium and potassium. We have already learned that down the group atomic radius increases. So if we want to remove electron from bigger atom, hence we need less ionization energy. Therefore, we said that down the group ionization energy decreases. Why ionization energy increases from left to right across the period? When I consider second period elements like lithium, beryllium, carbon and fluorine. We already know from left to right across the period atomic radius decreases. Similarly, nuclear charge increases. It is very difficult to remove an electron atom like fluorine. So, more ionization energy is required. Therefore, we said that the ionization energy increases from left to right across the period. So, that's all for this video and subscribe the channel. Bye bye.